right, so now that we've discussed inverse sine, I think the inverse cosine should go a little bit smoother just because you kind of have a foundation, an understanding, hopefully, of what's going on. But real quick, let's talk about the cosine graph. So when you look at this again, remember the cosine wave usually keeps going on and on, but then when the cosine wave is completely filled, it's not one-to-one. So we restrict it and cut it down. And so we're only going to look at one portion that is then one-to-one. So our restricted domain for cosine is going to be, we're just looking from 0 to pi, okay? And then remember that when you are graphing the inverse function, you are taking all of the key points that exist on that cosine wave, and you are going to flip them, okay? So 0, 1 exists on this curve. It's now going to be 1, 0, and so on. So I'm flipping all these points. Those are all going to be ordered pairs that exist on the inverse cosine wave. And again, also kind of like the shape goes the opposite direction, like the way it's bowed will flip a little bit. So here's what the inverse cosine graph looks like. Again, remember, it's super important that you remember the domain and range, okay? Because that's the piece that is pretty critical with what we are doing. So let's make a list down here like we did before. So for regular old cosine, we're going to say the domain for the restricted one anyway is 0 to pi. And the range is -1 to 1. Okay, that's for the black line, black graph up there. The inverse cosine graph will have the exact same domain and range, but they will be flipped. So the domain will be -1 to 1, which is just like sine, inverse sine, by the way. And the range will be 0 to pi. Okay. So here are some examples. They should look pretty much like what you just did with inverse sine, but I'm going to walk you through the process again because it's an adjustment. It takes a minute to kind of get used to. So start with this number inside. Make sure that that is in the domain of inverse cos. It is, okay? It's in the middle. It's in between these numbers. So then what you can do is you can go to step 2. In step 2, you're going to ask yourself, and I'll write it down here, when is cosine equal to 0? Okay, when is cosine equal to 0 in the unit circle? So let's find our unit circle. Here it is. When is cosine equal to 0? Well, cosine's the x coordinate. So if you go around and look at your x coordinates, cosine is 0 at pi by 2 and 3 pi by 2. So we have 2 places. So we'll write both of them for now, pi by 2 and 3 pi by 2. Okay? The third step is you're going to make sure that both of these answers are in the acceptable range values for inverse cos. Pi by 2 is between 0 and pi, so that is an acceptable answer. 3 pi by 2 is not. So you're going to take that out and you're going to keep only the answer that is in this interval. Okay, go to the next one. Radical 2 over 2, is that in between -1 and 1? Yeah, remember we checked in a calculator last time. It was like 0.7, I think, something like that. That is in this interval. So then we can go to the second step, and we're going to think in our heads, when is cosine radical 2 over 2? Okay, and again, the goal, you guys, the goal is for you to be able to do this without looking at the unit circle, okay? So you should be able to think about your angles that you know and tell when cosine is radical 2 over 2. But again, we're just, just learning the inverse stuff, so that's why I have this little handy unit circle chart to help us today. So pi by 4, yes, and then 7 pi by 4 is also where cosine is radical 2/2. So I'm going to write both. And you're going to check and see which of those is in the interval 0 to pi. Pi by 4 is the only one that fits in between the interval, the range values for inverse cos, so we only have one solution. Okay, a couple more. -1/2, is that in the domain? Yes, it is. So then we'll go to step 2 and we'll say, when is cosine -1/2? Okay, cosine is equal to 1/2 at pi/3, but -1/2 is not happening until 2 pi/3 or 4 pi/3. So we have two answers, 2 pi/3, 4 pi/3. So then you've got to look at your range. We can only accept answers that are between 0 and pi. 2 pi/3 is between 0 and pi, but 4 pi/3 is not. Last one, remember that if it says estimate, that means it's not a unit circle value, so you will use a calculator to do this. You still have to go through the procedure of checking to make sure that this is a domain value. Then you can go to your calculator, and you're going to want to make sure you're in radian mode. And then second cosine will get you to the inverse cosine function. Type in 1/3 and you get 1.231 if we rounded. 1.231. And that is in radians. And then you're going to want to check and make sure that that is in the interval between 0 and pi. Again, it's kind of hard to do with radians unless there's, because there's no pi there. So what you can do is go back and put your calculator in degree mode and kind of convert it to degrees that way. So it's about 71 degrees. And so up here, I'm thinking about, is 71 degrees in this range? Well, this is 0 and this is like 180. So yes. Okay, last inverse function is inverse tangent. So guys, it's basically the same thing again, except inverse tangent, remember, is just a bunch of the same kind of waves over and over repeating themselves. So we're just going to look at one of those sections so that it is a one-to-one function. So I'm going to go down here and write my domain and range like we've been doing. Okay, so the domain of regular tangent is -pi/2 to pi/2. Notice there are no brackets here. There's no brackets because that means for us, -pi/2 and pi/2 are not values that are in the domain. We just get really close to those numbers. The range is -infinity to infinity. Okay, so how does that translate to the inverse tangent function? So for inverse tangent, the domain and range get flipped. So it means domain would be -infinity to infinity, which it looks like that's the case for the inverse graph. And the range would be -pi/2 to pi/2. Okay, so let's do some inverse tangent questions. Same process again, okay? Here's the nice thing. Inverse tan has a domain of -infinity to infinity. So if you're doing that first step and you're checking to see if this number is in the domain, guess what? It is, because that means anything is in the domain, right? So it's not as restricted as the inverse sine and cosine graphs. Okay, so step 2, you're going to say, when is tangent equal to 1? That's how you're going to think through. And let's try this time without the unit circle in front of us. So when is tangent equal to 1? That would be at pi/4. Pi/4, and also, I believe 5 pi/4, because that's quadrant 1, and quadrant 3, that's where tangent's positive. So 2 answers. And then you're going to look at your range and see which of these two fits in the interval. So say bye to 5 pi/4, just single pi/4 is your solution. Okay, Check 0. 0's in the domain because everything is in the domain. So then question 2 is, when is tangent equal to 0? Tangent is equal to 0 at 0 and pi. 0 and pi. Which of those is in the acceptable range interval? Only 0. Pi is much bigger than pi by 2, so that would not be an answer. Okay. Third question, negative radical 3, is that in the domain? Yes, it is. So then you're going to say, when is tangent equal to negative radical 3? Okay. When is tangent equal to negative radical 3? Tangent is equal to radical 3. I'm going to worry about the negative later. For right now, tangent is radical 3 at pi by 3. It's negative when we're in the second quadrant. So that would be 2 pi by 3, or the fourth quadrant, which is 5 pi by 3. So second quadrant and fourth quadrant. Okay. Now, which of these is in the interval? Neither. So this is one of those trick questions. There is an answer, okay? There is an answer. It's just not written in the correct format. So what you need to do is think about your angles as in terms of negatives. So 5 pi by 3, that's in the fourth quadrant. That is the same as negative pi by 3. Okay, they are the same exact location in the circle, but negative pi by 3 is going to fit in the interval. So you have to make that change to get your answer. All right, last one here. What about inverse tan of 5? 5 is in the domain, so we are good to go. Grab your calculator, make sure you're in radians, and then inverse tangent of 5. For me, I am getting 1.373, and remember that's radians because we were in radian mode. And if you want to check your answer, you can switch back to degree mode and compute again. That's about 78, 79 degrees. That is in the interval because this goes from like negative 90 to 90, essentially. So that answer is acceptable. All right, so let's just do a few more. These are all calculator questions. You do still have to think through them the way that you had to do all the others, okay? Meaning, you have to start with this inside value, and you have to ask yourself if that is in the interval or not. And if it is, then you can go to the step of computing, okay? So let me give you an example. Let's start with this one down here. Is negative 4 in the domain of inverse tangent? Well, the domain of inverse tangent is negative infinity to infinity. So yes, it is. Okay. So then you could grab your calculator and you could compute what is inverse tan of negative 4. And I am getting negative 75.9637. I don't want to round it too much because I don't want it to affect my final answer. And then you're going to take tangent of that. You may want to type it in your calculator so that you're pulling the answer down rather than retyping the number in. But I want tangent of that answer. And it actually is equal to negative 4. Now, why is that? Well, because what does an inverse and a regular function, what do they do to each other? They cancel each other out, don't they? So you have to keep that in mind. Now, that's not always the case, but in this case, that is what's happening. The inverse and the regular cancel each other out, leaving you with just that component inside. Let's go up and try this one. All right, so sine of 2.36 pi is 2.36 pi in the domain of regular sine. Okay, let's go look. Not the inverse, okay? Not the inverse, and just regular sine. Well, your regular sine is continuous all the time, right? So yeah, that's This is the restricted one, but regular sine is always continuous. So yes, you can compute sine of 2.36 pi. And so you can go ahead to your calculator and do that. Make sure you're in radian mode. I have 0.9048 for that answer. Then you're going to do the inverse sine of that solution. So we're kind of working inside out. So I'm going to go back and I need to check and make sure 0.9 is okay to plug in. It is. It's in the interval in the domain values. So you can plug 0.9 in to the inverse function. So I'm going to do that again in my calculator. Make sure that you are in radian mode still. So inverse sine of 0.9048. Let's see. I am getting 1.131. Okay, now this time's a little bit funky, right? Because the inverse sine and the regular sine didn't exactly cancel each other out, did they? Well, that's because you have a value here, this 2.36 pi. That's not in the domain of the restricted sine wave. So you're getting a little bit of conversion happening that you're not seeing. Okay, so you have to be very careful and thorough with these problems. Okay, let's just do a couple more. So let's look at A. I think I'm just going to maybe do 2 of these, okay, and then we'll call it a day. Inverse cosine of radical 2 over 2. Now the question does say find this value without a calculator. So you're going to need to walk yourselves through the steps. What is the domain? Like, does this fit into the domain of inverse cosine? So let me go find inverse cosine. Yes, it's -1 to 1, and that value is in the interval. So we are good to go with this. Compute. So when you're computing this in your head, remember you're going to ask yourself, when is cosine radical 2 over 2? And that should be at pi by 4 and 7 pi by 4. Okay? But your inverse cosine has to have an output between 0 and pi. And this is the only one that's between 0 and pi. So pi by 4 is your solution. Okay, let's try this one down here. Okay, what is cosine of -1.1? Is -1.1 in the domain of regular old cosine? Yes, it is. So you're going to make sure you're in radians. You're going to go cosine of 1.1. And you get 0.45, okay? And then you would want to compute the inverse. So this question you're going to check is 0.45 in the domain of inverse cosine. Yes, it is. So your answer, you'll compute the inverse cosine. And you would get 1.1 again, okay? So what's happening here, to compute this without a calculator, what you would want to do is you would want to look at domains closer, okay? So without a calculator, what do? What you would do is you would start with this number here, and you would say, is it in the domain of cosine? Sure is. But what about inverse cosine? Is 1.1 in the domain of inverse cosine? No, it is not. So what could I do to make this easier to work with? Is this going to give me a value that actually exists? Okay, so mathematically, your answer for your inverse cosine function kind of needs to be positive, okay? So as long as you understand that these two values just cancel one another out, the only other thing you need to understand is that the inverse cosine value is just going to be the positive version of what it currently is. Okay, those are pretty tricky to do, especially when you're not thinking, when it's not given in radians. So you probably aren't going to see a question quite that complicated on a quiz or a test, okay? All right, I think that's good for now. What I might do tomorrow is I may send you a video to help you with a few of the homework problems. But for now, I'd like you to try to get started on that assignment. And then, if you're starting to have some trouble, just let me know.